thank you all for tuning in today. It's nice of you to spend your lunchtime with us. We've got a little bit different format today. Rich Delaney couldn't make it, so Owen Nichols, who's director of our Marine Fisheries Research program, is the moderator of the discussion today. And he also happens to be the presenter, which is very useful. So if you have any questions for Owen or for the panelists, that's Doug or Alex, please use the Q&A button on your screen. If you're on laptop, it's down at the bottom. If you're on your smartphone, it's up on the top. And we'll get to as many of those as we can. So without further ado, I'm going to hand over to Owen Nichols. And do enjoy. We'll talk to you soon.
Great. Thanks, Catherine. I'm going to assume that everyone can hear me okay. Yeah, it's a real pleasure to do this. As Catherine said, we have a bit of an unusual format today in which we're also inviting a couple of other speakers from other places and other institutions. Commercial fisherman Doug Feeney is joining us today from the Fish Pier in Chatham. He's calling in from the deck of his boat, I believe, so it doesn't get any more authentic than that. And then Alex Bocconcelli from the Woods Hole Oceanographic Institution is scheduled to join us as well here. I think probably what I'll do while we wait for both panelists to be able to join us, Doug is here, but we're still waiting on Alex. I'm going to tell you a little bit about our Marine Fisheries Research program in general, and then we'll take a moment to introduce my other partners on this project and our panelists today on this webinar, and then we'll talk a little bit more about the research that we do, and particularly the project that we wanted to talk about today. So I'm going to go ahead and share my screen here. And I'm hoping everyone can see a screen that has the title of today's presentation on it. And I want to give you a little bit of an introduction to our Marine Fisheries Research program. You know, the Center for Coastal Studies is very well known for its work on large whales, but we also work in a variety of other disciplines and fields. And so I want to tell you a little bit about our fisheries program. We've had a fisheries program for about a decade now. And really the work that we do is focused on our small boat fisheries around Cape Cod. You know, for many of you, I imagine, who are calling in today or tuning in today are familiar with our fisheries around the Cape. But for those who aren't, I do want to point out that our fisheries here are relatively small scale. There are a lot of really, really productive fishing grounds close to home here around Cape Cod. And Cape Cod, of course, taking its name from the rich cod fishery, a very long history of productive marine fisheries all around us here on the Cape. To that end, our boats are often small, you know, what we call day boats, boats that go out and come back the same day or within a couple of days, making relatively short trips, working close to home. And a lot of these are smaller scale owner-operator operations. And that's really important because a lot of times fishermen, you know, who work individually, they may not be part of a large association. You know, they often need individualized, individually tailored answers to management questions, scientific questions, whatever it is. So our program really works with a lot of the small scale fishermen working around Cape Cod. And the work that we do through our Marine Fisheries program, we're really trying to foster collaboration and understanding between fishermen and scientists, you know, really trying to create a dialogue between those communities, between the fishing community and the scientific community. We conduct a lot of outreach, we do a bit of education work, and I'll touch on those things. And the bulk of the work that we do, including what we're going to talk about today, is research. Now, we focus on scientific and policy issues, really confronting local fishermen here around the Cape, fishermen and shellfish farmers as well. And usually those conversations start in a way where we're asking the questions of the fishermen, of the fishing community, you know, what do fishery managers need to know that they currently don't? And how can we work together to get that information to them? And conversely, fishermen often come to us with very pointed questions. You know, why don't we have an answer to this particular question? Or, you know, where do fisheries managers get this data? This doesn't make sense to me. And those are often the beginnings of those very important, very powerful conversations that start new scientific investigations and really working in direct partnership with the fishing community. This isn't about, you know, a scientist getting an egg-headed idea and then chartering a boat and taking it out, you know, having the fishermen drive the boat around while we put gizmos in the water. This is really very much about working together right from the beginning, you know, true collaborative scientific investigation. And I see we have another panelist joining us. Hello, Alex.
Hello, how are you?
Great. I'm giving just a quick introduction to our Marine Fisheries program, and then I'm going to turn it over to you guys for a minute just to introduce yourselves. We'll talk a little bit about our project in particular, and then I've got some questions for you and Doug to discuss with our audience, if that's okay.
Great, great.
Wonderful. So a big part of what we do is, you know, outreach and engagement. Again, going out to the fishing community. You know, you can't sit in your office, especially not these days, but certainly under normal times, you know, we're not sitting in our offices. We're going out into the fishing community. You know, we're having these very important conversations, and a lot of us, you know, yeah, we try to find fishermen at the dock, at the coffee shop, wherever we can, but we go fishing too. You know, the scientists that work on this program, on this project that I'm going to talk about today, that we're going to talk about today, you know, all have extensive experience going out fishing, going out as crew, you know, learning about the fisheries, you know, firsthand. You know, it's a really, really important relationship to have. And it's where a lot of these complicated conversations start. So that said, you know, the bulk of the work that we do is research. You know, we're working together on the boats offshore. These days we wear our masks, but otherwise, you know, we're still working. We're out there. We're doing these kinds of projects. And, you know, one of the strengths of these partnerships and one of the important reasons for even just maintaining a dialogue with the fishing community, let alone the importance of doing applied research, is the fact that fishermen are on the front line of ecosystem change. You know, as we see all kinds of things happening out in the marine environment, you know, the fishermen are the first ones to really see it. And quite often, because we have that solid relationship with the fishing community, we're the first ones to hear about it. And whether that's an influx of squid or some unusual species, you know, caught offshore on the boat, whatever it is, you know, the fishermen are there sharing that information, and that's really, really important. We also work a lot to kind of train the next generation of fishermen and fisheries students and fisheries scientists. We work a lot to bring fishermen to the table as educators, teaching our interns how to do everything from mend twine to run a boat. And a lot of the younger fishermen that are crew on the fishing boats also become part of the conversation and learn a lot of the fundamentals of fisheries science as well. So we really try to bring a strong program. Again, we create a situation where many of our fishermen become faculty, whether it's through our course up at Shoals Marine Lab or working out at the Massachusetts Maritime Academy. We're developing a course there where fishermen essentially become professors during the semester. And a big part of that from the science side is involving fishermen all the way through, again, from that beginning stage, you know, from developing hypotheses, figuring out what the important questions are, all the way through to reporting results. And in many cases, fishermen are co-authors on scientific publications that are published in the peer-reviewed literature. That's a really important thing, as many of you know, for scientists. And if fishermen are making the same level of intellectual contribution to a research project, then absolutely that merits co-authorship on these papers. And finally, a little bit of what we're doing today is we really try to involve fishermen in the outreach to the broader community, not just the scientific community, not just to the fishing community, but also to that broader community of people. And, you know, so today you'll get an opportunity to hear from one of the fishermen that we work with, Doug Feeney. We're going to hear from a scientist, Alex Bocconcelli from Woods Hole Oceanographic Institution. And I think with that, what I'll do, I'll stop my screen share for just a moment. I do want to give both Alex and Doug a moment just to quickly introduce themselves. You know, in just a couple moments, tell us a little bit about your experience, both as fishermen or as scientists or both. And we're going to circle back later on in the discussion today to talk a little bit about, some of the things you've learned during this particular project. But in general, and I'll give it to you, Doug, first. I'm going to stop my share here, and hopefully, Doug, you can unmute yourself and tell us a little bit about your history of fishing.
Yeah, sounds good. Can you hear me, Owen?
I hear you fine, thank you.
All right, the motor's not too loud. So I'm Doug Feeney. I'm a commercial fisherman of 25 years, Chatham, Massachusetts. I've seen tuna come and go and come back again. I've seen tons of codfish and I've seen them go, and I don't think they're coming back again. So there were some questions looming in our minds as fishermen, and we had we reached out to Owen and other participants, and graciously they agreed to collaborate with us and try to figure out what's going on in the ecosystem. That's about it, Al.
Yeah, great, Doug. Thank you so much. And we'll get back to you after we show a few more slides here, and encourage you to join the discussion. Alex, what about you? I think you're muted, Alex. There we go.
Yeah.
Welcome, Alex.
Thank you. I had a few technical problems here. But anyway, I am a research specialist at the Woods Hole Oceanographic Institution in Woods Hole on Cape Cod. And in my previous life, I was also a commercial fisherman, both in Italy and in New England. And I love both of them, but fishery and being a fisherman was my first love. So for me, this project was the best because I could put together two things that I really like to do and I'm very interested in. And, the idea was to basically marry technology, science, fishery experts like Owen, seal experts like Andrea, and then a real fisherman with a lot of experience like Doug. And I think the union, the marriage, the multiple marriage worked out very well. It was a very satisfying project, and I hope we can, get more funding and keep progressing in what we are doing and keep working with the fishermen in Cape Cod.
Great, thank you, Alex.
You're welcome.
Yeah, we'll circle back to you later on as well. So I'm going to go back to sharing my screen here. Alex, if you can put yourself on mute there again, just in case.
Yep.
Thank you so much. And thank you for our audience, or to our audience, for bearing with us through all of these technical things here. You're all doing great. So as both Alex and Doug alluded to, we are part of a much larger project team. First of all, I want to acknowledge that this particular project was funded both by the Marine Mammal Commission and then extensively by the National Marine Sanctuary Foundation. And again, this is a big team of people. One of the other principal investigators on the project, Dr. Andrea Bocconcelli, contributed enormously to this project during her time at the Woods Hole Oceanographic Institution. We have folks who are working specifically on looking at questions about seal diet and related to some of the animals that we've looked at during this project. And we may touch a little bit on that today, but in particular, I want to acknowledge Lisa Setti at the center, Keith Hernandez, a PhD student, or now newly minted PhD, and Fred Wenzel at the Northeast Fisheries Science Center, all of whom have contributed to the diet analysis portion of this project. I want to acknowledge the very large number of students and assistants who've helped with the video data analysis part of this project, and I'm going to show you guys some video today. You'll get a feel for what those students and volunteers have endured watching some of this video. Some of it's really cool. Some of it is probably a little bit mind-numbing. But in particular, I want to acknowledge Jessica Vo, Juliana Berube, both of whom were interns at the Shoals Marine Lab, and continued in their work on this project after their internships were over while they were undergraduate students at UMass Amherst, and have continued to support this project out of their own time because they really want to see their analyses through. I also want to acknowledge Corinne Loesch from AmeriCorps Cape Cod, Carolyn Hanrahan, who's a student from St. Olaf College, who's been assisting me, and then Isabel Cadane, who's an undergraduate student at Roger Williams University, who's going to be doing some more analysis of this data as well. And then finally, I do want to acknowledge also Doug's crew. Doug has quite a few folks that work on his boat, but I particularly want to acknowledge Tim Weldy, who is part of the project through much of this, whose name I frequently misspell, and I'm sorry for that. But anyways, so that was a long introduction, but it's really, really important for me, you know, to acknowledge the broad contributions of so many different people on a project like this. So sorry for taking so much time for that, but I really, really think that's an important part of this process. I'm going to get into a little bit of the project itself here. So we have the Gillnet fishery off of New England here. And I'm going to talk a little bit about, in particular, the fishery that targets skates using large mesh gill nets. There's a kind of a day boat fishery in particular that operates out of Chatham that goes out for 1 or 2 days at a time, sometimes using 2 different mesh nets, large mesh nets for skate, smaller mesh for dogfish. We're going to talk a little bit about the skate fishery today, and I'll show you a little bit of a close-up view of a gill net. Now this is kind of a lake gill net. This is a sort of a stylized diagram from Michigan Sea Grant of what a gill net looks like in an inland waterway. The gill nets that our fishermen use are a little bit different design, but it kind of gives you a good graphic of how a gill net works. So it's anchored to the bottom at either end. It's essentially a series of mesh panels that hang in the water column. There's weights at the bottom of the net. This is what's called the lead line. And then there's the float line at the top that keeps the net up in the water column. Sometimes lines are tied from the head rope to the foot rope to create pouches that help catch different species or allow other species to go past. So those are kind of the key elements of a gill net, and the way this works, and you'll see this in practice, is that as fish are traveling through the water column, they'll become enmeshed in this net. It's what's called a passive gear or fixed gear. Then that gear will be retrieved to the surface. The fish that are in that net that you want to keep get taken. The ones that you want to let go get let go. And the mesh size itself is one of the major controlling factors. You know, in general, very small fish don't get caught in this gear. You know, depending on the size mesh, that really dictates what you're going to catch and what you're not going to catch. That said, we do have interactions between gear like this and species you don't want to catch, whether they be fish of a species that you don't want to bring home, or in some cases seals as well, or other protected species. And so that can be an issue for fishermen. We also have an issue with interactions between predators in the catch that's retained in that net. And those predators can take a lot of different forms, and we'll talk a little bit about that. But one of the words that I use in this presentation is depredation, and that refers to the act of an animal removing catch from the net. And I'll show you some examples of that. Many of you know that in the last decade or so, we've had increasing abundance of seals in our local waters around Cape Cod. And with that has come an increasing number of interactions. You know, when you look at data, whether it's fisheries observer data, bycatch data, you know, fishermen are coming into contact with seals on an increasing frequency at sea, whether it's gill net gear or other gear. And this can lead to bycatch, you know, the unintended catch of seals. This can lead to entanglement of seals in the gear. The seal might leave a big hole in the net, but take with it enough gear that it becomes, carries a life-threatening entanglement with it. And this also results in situations where seals are often damaging or removing fish entirely from the nets. So as Doug mentioned, and Alex mentioned, you know, we got together a while back, you know, a group of fishermen and scientists together and started asking some questions around these issues. You know, Doug in particular was really pushing us to get out there, get on the boat, see what he sees. And so that's kind of the first part of the research story here, is a couple of us just getting out on the boat and, you know, taking photographs, documenting what's happening, you know, working with the fishermen, observing the catch, taking photographs of damaged catch. And this is a great picture, maybe a rare picture of Tim and Mitch smiling. I don't know if this happens when we're not on the boat, but they're smiling here as we pick the catch from the net. And, you know, we're examining the catch, we're looking at the fish that are coming out of the gear, and in particular, we're looking for damaged catch, and we're recording kind of the percentage of the catch that's damaged and trying to understand what the predator might have been that damaged that catch. So here's an example of that. We're using a system that was developed in part by a master's student, Laura Cyrak at the University of New England, who also worked with commercial fishermen to develop a way of assigning sort of predator bites to different species based on what we know about bite marks and dentition. And we're continuing to kind of refine that approach. This is an example of a skate. This is one of the target species. This is one of the species that Doug hopes to bring home in one piece. But in this case, it's got the belly ripped out of it, presumably by a seal based on our analysis. Here's another skate with a couple of different kinds of marks on it. A smaller bite there, presumably either another skate or a dogfish. There's also some unspecified other marks there that could be tooth marks from a larger predator, or nail marks from a seal, claw marks. You know, some of these are a little bit more difficult to assign. This could have been a large shark as well. But again, trying to use the bite marks to make some inference about what's down there eating the prey. So that's one part of the approach, but, you know, we really wanted to know, okay, what's going on beneath the surface? You know, we can only interpret this information that we're getting on deck so far, whether we're looking at photographs of damaged catch, listening to Doug's reports of what he's seeing. You know, what else can we learn? How can we observe how animals are interacting beneath the surface, down where the gear is? Because a lot of times as scientists and fishermen, we're left to make a lot of assumptions based on what we see up at the surface. So, you know, being very visual creatures, you know, three-dimensional people, Doug, Alex, Andrea, and myself all got together in Doug's backyard. Doug hung up a bunch of gill nets, and we started thinking about how we would go about putting cameras on the nets to see what was going on beneath the surface. Here are some examples of us trying to figure out the best way to attach cameras to Doug's nets. And here's from one of our first deployments of actually putting an underwater camera on a gill net. And, you know, this is certainly not as easy as it might sound. First of all, these camera packages need to have the right buoyancy so they don't weigh down the gear or float the gear up too high. We tried a couple different deployment configurations, and I'll talk about that. But the way these cameras work is essentially they have a long life battery in them. They're just essentially off-the-shelf GoPros, but with a specialized underwater housing provided to us by our colleagues at Marine Imaging Technologies. And these systems are able to record for up to 12 hours at a time, assuming the batteries are charged and everything is going well. And so what you have here is a couple of us affixing the camera to the gill net. That gill net is going to go off the stern of the boat. And, you know, we always wait anxiously until it's time to recover that gear. Here's an example of one of those camera housings coming up. So the gill net is being hauled back to the surface on board the boat. You can see a skate in the background also caught in the net. Here's the camera housing coming across the board here. And that's always a good moment. You know, every time a scientist puts a piece of equipment in the water and gets it back again, that's a small win. And at any rate, that's one of the tools that I'm going to talk about the most today is the utility of underwater video to answer questions about what goes on beneath the surface. And here's an example of one of those housings on the bottom, seen from one of the other cameras as we experimented with in different deployment scenarios. We often face them in opposite directions. Here, you're actually seeing one of the cameras on the seafloor in its pressure housing. We had an unfortunate incident where we saw one of them gradually filling with water on the video. That was pretty sad, but in general, these things work very well. Here's another shot of a gill net stretched out across the bottom. You can see our camera housing at the right, and you also see a little hake peeking in here, looking right into the camera, and you see this fairly frequently. But But I think with that, what I'm going to do is, that was just a quick introduction to the project, to the video component of the project, and I think that's what we'll talk about the most today. I'm going to go ahead and see if I can share a video, and we'll talk a little bit about the video technology that we use. Let me see if I can find the video among all of my screens here. It'll take me a moment. Stand by. Reshare, I think. Thanks for bearing with me here for a moment. There we go. Oops. Okay, can everybody see a video screen? Can somebody just let me know in the chat if they can see that okay, or give me a thumbs up. Alex, can you see the video? Oh, Janet, thank you, Jan. Jan's raising her hand, I think. Okay, great. All right, so I'm going to show you some underwater footage from these camera systems. You got to also get the audio here, I think. I don't know if you can hear it or not. It's not that exciting, but so there's a few things to watch for here. First of all, you can see there's a bunch of what we call sand dollars here. So back this up just a bit. Yep, these are sand dollars. These are echinoderms, kind of like sea stars. And there's almost always a crab that at some point while we're viewing this video makes an appearance. This is a rock crab or a Jonah crab. We see these a lot. You know, and what's really interesting about footage like this is a lot of times you're seeing things that aren't necessarily caught in the net. So again, you know, sometimes we do see these crabs in the year, but a lot of times you don't. And I want you to focus on this little point right here where my cursor is. You can see some sand lance or sand eels in the footage now. There's small fish darting around. Boom. I don't know if you guys could see that. That's some kind of a sculpin there, kind of an ambush predator. It's watching those sand lance go by. Bang. So you see all of these different kinds of predation events on the video, which is always interesting to see. And you know, as I mentioned, we have students that are working on this video. I'll show you some clips later on of the sort of the analysis that the students are doing, just so you get a sense for how much work it takes to actually look at all of this stuff. I mean, we have, you know, hours and hours and hours of footage. You know, sometimes we'll have 5 cameras on a Gillnet, each one of them recording up to 10 hours. So that's just 50 hours of video from a single deployment. And we have students and assistants viewing this, cataloging their observations and their behaviors. So I'm going to fast forward a little bit here to the next clip. You can see that sculpin enjoyed a meal of sand lance here. But we see a lot of other creatures here. That's just a still of a huge school of dogfish swimming overhead. You'll see more of those. This next little bit of footage here, what you're looking for is little silvery reflections here. Those little reflections are sand lance or sand eels. They're one of the most important forage species or bait species. They're food for a lot of different marine animals. They show up in the bellies of seals, of predatory fish. You know, they're really kind of one of the engines that drives the marine ecosystem out here. And it's really cool to be able to see these in place in the natural environment, because a lot of times we don't sample them. They don't come up in nets or trawls. So it's really cool to actually see them exhibiting their natural behavior here. They're called sand lance or sand eels because they bury themselves in the sand periodically. And you can actually see that from time to time in this footage where the sand lance are actually tucking into the sand and coming back out. You may also from time to time see predatory fish swimming overhead. And it's really important for us to see these predators, or sorry, these prey items down at the bottom. I hate taking such a beautiful, beautiful thing and diminishing it to something as like a prey item, but it's really important because a lot of times we're asking questions of, you know, the animals that come over the rail. You know, what are these animals eating? Oops, something just spooked that school of sand lance there. You know, what are the larger predators eating? Are they getting caught in the net because they're feeding on these smaller species? You know, these nets in general, that, you know, they're not baited. So, you know, they're entangling the fish, the skates in particular, they're targeting. And so are the skates and sometimes the seals or other animals that are getting stuck in this net, are they there because they're chasing those small bait fish? So this really gives us a sense of what's happening down around that gear. And it's also really cool just to be able to see the seafloor. You know, there's so much more data here than we can talk about just based on what you're seeing on the bottom. That's a moon snail egg collar. Here's once again the crab making another photobomb here. This is what they do. They're constantly patrolling that seafloor, and sometimes they spend a lot of time on or around the camera itself. You can actually hear the crab's legs kind of skittering over the camera housing itself. Even just the acoustic environment around this gear is fascinating to listen to sometimes. Obviously, we could watch this all day, but I'm going to fast forward a little bit here. You know, this is just sort of a compilation of some of the different things. Here's that crab. See the beautiful, beautiful markings typical of a rock or Jonah crab there, scraping along the camera housing and blocking the frame for us for a while. These crabs and us have a complicated relationship. I know some of you could watch that all day, but I'm going to move past that a little bit here. That's probably quite a few minutes of behavioral data potentially lost for any other animals that are there because the crab is hogging the frame there. More sand lance or sand eels swimming past. You can see predators chasing those. That dog was in my house, not on the video. Again, I know I could watch this all day, but it's just a tiny bit more. You know, it's pretty amazing watching these sand lance. And again, we do see these fish in the bellies of seals that get caught in the net. We see them in the bellies of the skates that are getting caught in the net. So really understanding the kind of predator-prey dynamics that are happening just around this net over the time that it's in the water is really, really important. We can use information like that to gain a better understanding of how the nets fish, why certain things get caught in the nets at different times. So what you're seeing now, this is a pretty typical example of what the students and researchers see when they're analyzing this footage. This is a software program called Boris. It's an acronym. It's a behavioral analysis software. So you can see, in this case, spiny dogfish swimming overhead, swimming around the net. The students are logging the events that they see in the program as they're watching the video. You know, and this is all happening not in real time, of course. This is looking at the video that's recorded and viewing it back in a laboratory environment. And what you see right there, I'm gonna pause it and bring it back here. You know, we talked about predators feeding on the catch in the nets. So there's a skate that's stuck in the net, and what you're seeing there is a spiny dogfish coming by and taking a big bite out of that skate there. And you can see it's already had a couple bites taken out of it. So these dogfish are voracious predators on the catch that's in the net. In this case, a school of spiny dogfish is swarming around this net here and taking bites out of a large skate, probably a winter skate that's meshed in the net here. So taking big chunks out of it. And again, you know, I imagine this probably gives you a sense of just how much work it is to actually analyze all of this data. You know, I can't emphasize enough the work that our students and volunteers do to help us analyze this data. But a great look at a dogfish predating on a skate that's stuck in the net, coming back for a couple more bites there. I'm going to fast forward a little bit more here. You know, there's some really amazing things that we see here. And just to orient you, so what you can see here, you can see hopefully see my cursor there. There's the floats that are holding the top of the net up, the foot rope or lead line along the bottom, resting on the seafloor. You know, you don't really see the mesh of the net in much of this video, and that's the same presumably for the animals that are getting caught in the net, just to give you a sense of how that works. I'm going to fast forward again just a little bit further here. Just to give you a sense, I mean, there's an enormous amount of work required to go through all of this video. Here's another view, in this case, of a school of spiny dogfish around the net. You can very clearly see, and this is one of the cameras that we had floating up towards the head rope of the net. It's off the bottom a little bit. So you can see the lead line, this rope that's along the bottom. You can see the head rope up here, float line. And what you're seeing is all of these dogfish just swimming right through that large mesh net. Remember, the net is big to catch skates. So the idea is a net this size is going to catch skates, but not catch dogfish. So it's very rare that you get a spiny dogfish like these small sharks here actually stuck in that skate net. Every once in a while, you'll get a big one that gets itself tangled in the net. But generally, it's a very selective gear in the sense that it's catching mostly good size winter skate, and it's not catching very many other species. And this is a great sort of textbook illustration. The net is towards the left side of your screen as the camera kind of pans back and forth on the tide. And those dogfish are going right through it. You can also see a couple of skates meshed at the very bottom of that net there as they travel along the seafloor. And so we've got students that are looking at this, in particular looking at how the net fishes with respect to different species. You know, what are some of the reasons that more or less skate get caught in the nets? Does that have to do with predators around? Does that have to do with how many skates might already be in that net? You know, we have a lot of different questions. And we are looking at some of the factors that affect damaged catch. You know, do we see a direct correlation between the number of dogfish swimming around the net and damage to the catch? Or is there some other factor that really causes more damage to the catch? Same is true of interactions between seals and the nets. You know, we've seen that only very rarely on video. Many of the interactions that we know about happen in the dark, and we've been doing some limited nighttime observation by putting red lights on our nets. You know, red lights being better for seeing at night, but in a wavelength that most marine animals don't see. So we've been experimenting with that a little bit, but you know, the challenge remains is that it's tough to see in the dark. But we are starting to be able to make some really interesting inferences about some of the things that are going on around the nets, even during the day, and how that relates to what's happening at night with respect to interactions between seals and the gear. So we've got a lot to learn. We've got an enormous amount of data. You know, I could watch dogfish swim all day. You know, these are just some more examples of some of the damaged catch that we talked about, and those ways of looking at what happens on deck here. You know, a lot of times we just get these remnants that have been consumed by crabs and other species, and then we have to figure out what happened. Here's you know, another example of a skate meshed in that net. The net's a bit tangled here. So these are the kinds of things we're looking at. You know, there's a lot more to this story. You know, there's a lot more to sort of untangle, if you'll forgive the pun. I'm going to quickly show you just kind of one really cool video that one of the former students that's working on the project sent to me. Then we'll kind of close out with a video here. And I would love to start both answering some of your questions, and also I've got some questions that I kind of had queued up. You know, I'd like our panelists to speak a little bit here first. So in fact, looking at the clock here, given that it's already 10 past 1. If we have time, I'll show one more little short video clip, but I think for now, let's end the video here. I want to give Alex and Doug some opportunities to answer some questions here. I'll take a look at some of the questions we're getting from our audience here through the Q&A function. But first, let me just ask, and I'll ask Doug first. You know, I'd love to know, let me make sure, are we back off screen sharing here? I think so. You know, I'd really like to ask Doug in particular, you know, what are some of the things that you've learned while doing this project? And I'll kind of ask the same thing to Alex. Doug, are you still with us?
How about that?
There he is. Got you now.
All right, sorry. All right. Question again. I'm sorry. I got somebody diving under the boat.
That's okay. You know, I was wondering, you know, I'm curious to hear your perspective, you know, of some of the things you've learned so far by doing this project.
Well, I've learned a tremendous amount. The relationship of everything down there is quite fascinating. You know, I think it was pretty mutual to everyone that when we put cameras down in the daytime, we thought we were going to see a whole lot. But we learned that it all happens at night like a party down there. It's totally different between the day and night. The ocean comes alive at night. And to see the different species at what depth they travel was mind-blowing, because in some of the footage, we see schools of haddock, you know, 10,000-pound schools swim by the gear, and yet they're up above the gear, going over the gear. So that's really interesting. It's quite fascinating. And just to see it, you know, to finally be able to see it and see what's going on. You know, we both have opinions on what's going on, but to actually see it firsthand is quite amazing. I really need that night footage, though. We gotta figure that one out. But I've learned a lot.
Thank you, Doug. Alex, I'm just curious, you know, what kind of what some of the things that you've learned by working with Doug, by working as part of this larger group. Oh, Alex, I think you're muted if you're trying to speak.
Yeah,
there we go.
It was, okay. I'm using the phone because the PC is not working. But it was very interesting for me to see how the gill nets actually work as a harvesting tool, because I think I started to use gill nets in Italy when I was 10 years old. So that makes it 53 years ago. But I never took a look at them underwater to see actually how they work. You know, you just drop them and hope for the best. So yeah, the fact that, to me, it seems like once you drop them on the bottom, then, you know, after a while, they kind of become like a fish aggregation device. It seems like everybody shows up to see what's going on, and then some fishes get caught in the net, so the predators arrive, all kind of predators. Very, very interesting. And also to see how, you know, the tool actually works, how efficient is the net as a harvesting tool. And I was really surprised to see how selective it was, at least in this kind of fishery, which made me very happy. I was disappointed that we didn't get any of the big predators, you know, caught them with their hands in the cookie jar, but hopefully we will one day. I think, you know, the monitoring tool we use were whatever we could afford with a very limited budget. So, and I'm working on a new proposal to build these new cameras. So hopefully in the future, we can really improve this kind of monitoring and learn a lot more about, you know, depredation and also fish behavior around fishing tools. So that's what I learn, and that's what I want to learn.
Great, thanks, Alex. Yeah,
You're welcome.
that kind of segues into my next question. So, you know, that I was going to ask both of you kind of what you think the next steps are. And I think both Alex, you and Doug kind of mentioned the fact that we need more imagery, particularly at night in the dark. You know, that's one of our biggest challenges. You know, the red lights, you know, the footage, I could show you some of the footage if we have time, but, you know, we can see things. And in fact, we've observed seals on that footage. We've seen, we've been able to capture one animal entangled in the net. We're not sure that we actually capture the actual entanglement event, but we see it on that footage as the light improves. You know, it is really challenging. You know, the marine environment, you know, if you use a light underwater, you have the potential of affecting behavior of the animals down there. The red light, of course, less so based on what we know about underwater vision of some of the other animals. But that illumination also creates a situation where you have, you know, essentially it looks like you're driving in a snowstorm. You know, all of the flocculant, the marine snow, the particles down there really clog your view field as well. So it is really challenging. Doug, are you able to share? You know, you mentioned having more footage at night. Do you have any other thoughts on kind of the way forward here, kind of the next steps? And otherwise, I'd like to start taking some panelist questions here. I see a few in the Q&A box.
Yeah, Owen, I do. So my thought is, you know, I'm a little bit baffled that we started a project, to be honest, that is quite a contentious project and, you know, on everybody's mind, but yet here we are dead in the water. I'm confused by that. We need footage at night, simple as that. And it's going to take the proper cameras to do that. And yeah, it's just, that's what we need to answer our question and to get evidence and to see it all actually unfold is going to be at night. And it can't be, you know, it's got to be the proper equipment.
Yep, agree. That's one of the biggest challenges. You know, a lot of what we're learning, you know, we've made some inference based on stomach contents of either seals captured as bycatch, you know, correlating that with the observations of what's underwater for smaller prey fish and things like that. But you're right, there's a lot more to learn. And, you know, we really kind of set out with this idea of capturing this direct interaction. And we haven't yet been able to do that the way we'd like. So yeah, more cameras, maybe using some other underwater imaging technology. You know, I've worked before with high frequency sonar, which is another tool you can use, kind of an acoustic camera. But, you know, the more complicated the gizmo that you put down there, the more issues you potentially have. So, you know, I'm excited about, you know, the promise of developing a new camera system. I know Alex and other folks are working on that. You know, a lot more questions to answer. You know, we really kind of threw a lot at this question, from on-deck observations to looking at stomach contents of bycatch animals to the underwater imaging. You know, we're still piecing the puzzle together here, even with what we have. You know, we have an enormous amount of data with which we can answer some questions and make some inference, but there's still a lot more to do. You know, what I was hoping to share with everyone today is kind of the process. You know, we don't have that many firm conclusions yet. It's really about the process of investigation. And you hear, you know, the sort of iterative approach of scientists and fishermen trying to figure out how to do something together. What happens when we don't come up with the data we hope to get the first time around? You know, we're continually trying to answer questions and figure this out. You know, one of our panelists asked, you know, what are the conclusions, you know, and unfortunately, like Alex and Doug said, at this stage, you know, we still have a lot of questions, and in some cases we have new questions. You know, we're trying to look at the prey field around the nets from the video and from the stomach contents of predators and prey to answer these kinds of questions. We've got some other great questions here from our audience. Two folks asked about how far offshore the nets were and at what depth. And without being able to quickly pull up a data sheet, maybe Doug, you could answer that question as far as the depth we were in and about how far we were offshore for most of this work.
Anywhere 8 to 14 miles depth, 16 to 24 fathom.
Great. Thank you. Yeah, so anywhere from 8 to 20 miles offshore, depth anywhere from 16 to 24 fathoms. So you can see we have a fair amount of light, even during some of those deeper deployments during the day. Yeah, we're impressed with the clarity of the video that we could get during the day, but as we started to realize over the course of the project, the phenomenon that we were really trying to capture was happening much more at night. And that in and of itself, of course, is a finding that, geez, this thing that we're trying to document here is really happening at night rather than during the day. We've got quite a few more questions from the panelists here. These are great questions, everybody. A question for another one for Doug. What was the hardest thing for you about working on this project? It's a two-part question. What's the first part?
Yeah, I guess so. What was the hardest thing? Okay, I made a statement a while ago that I wish I could take back, but it usually goes, when I do something, I like to see something to the end, and for us to be stuck right now is my hardest part. That's everything else was gravy. As long as we were fishing and collecting data at the same time, it was all good. But now that we're at a standstill, it's not so good.
Yeah, I hear you. And as Alex alluded to, we're all trying to find more funds to do this work. So we're doing what we can on our end from behind our desks here. The second part of that two-part question was, what do you think we need to do to create more projects? What do we need to do more work with fishermen and scientists working together? That's more of a general question, not just specific to this work.
Breed more people like you. Really, it comes down to, it comes down to just making the introduction. I had a question. We both sort of had the same question. We just came together with it. If it wasn't for Center for Coastal Studies, Andrea and Owen, I would have never been wrapped up in this business. But I made the introduction to, I think, one of your talks, and then it just ballooned from there.
Well, that's a very high compliment, Doug, coming from you. And I agree, we need one of the things I would say is it's really encouraging is that there are, there's this generation of fisheries scientists coming out of some of the universities right now that are, they're kind of getting back on the water. I think, it's exciting to see that most of the people entering the field right now as, fresh grad students have a lot more field experience than they did maybe, a decade or two ago. It used to be that scientists routinely went out on fishing boats. In fact, for many of them, it was their only way to get out on the water. And I think we're seeing an increase of that in the last couple decades of, more and more students and early career scientists recognizing the value of that collaboration, and universities doing their part to get students out on the water and talking to fishermen. A very specific question about gillnets themselves. The question was, is there a technique for sort of estimating the efficiency of gillnets? So, how are they fishing relative to the time underwater? And we actually have a couple of our students are trying to answer those kinds of questions where they're looking at, catch in the net over time and trying to look at the factors, that affect the efficiency of that gear over time. So that may be one of the questions that we can start to answer even with this video data. I mean, as I've mentioned, we've got, hundreds of hours of video, and much of it can be used to answer those kinds of questions. But you can look at catch over time, the number of fish per unit area of the net over time. So there's some great questions we can continue to ask of this data, and probably quite a few student projects in there. I had one question, is there any attempt to look at sort of the socioeconomic impacts, so the effects, for example, in the fishing community of lost catch, it was kind of beyond the scope of this particular project, but some folks have attempted that in the past and likely will continue to do so, looking at the damaged catch and sort of extrapolating that up to economic value for the fishermen. That wasn't something that we were trying to do here. We're really trying to capture more of the ecology and biology and interaction right around the net itself. But really, really important questions, of course. I think we're starting to, I don't see any new questions in the Q&A box, but some great questions from our audience, from our panelists. And I think with that, I don't know, Doug or Alex, if you have any sort of closing remarks before we say goodbye to everyone here.
Yeah, I do. Oh, quick.
Please.
Like I said, it's been a wonderful, eye-opening experience for me to actually see how things work down there. Usually I'm looking at something that shows yellow fuzz or green fuzz or some sort of fuzz on a hump or a bump, but to actually see stuff down there, like the rock we barely missed with the gear, that was really, really sort of special. And working with the three of you has been quite a pleasure too. So I look forward to a lot more of it and answer a lot more questions, because like you said earlier, which I really liked, was, there's a lot more new questions that have shown themselves. And I find that fascinating and interesting, and let's solve them. Thank you.
Thanks for joining us, Doug. Alex, any last comments here? And I realize that there was a bit of a lag for me in the Q&A box here, so if I have time, I'll try to answer one or two more audience questions. But
well, I just hope we can get some proposal accepted and funded, and we can make Doug happy and figure out what was going on underwater at night. We know what's going on during the day, not much. Still very interesting, and I think if we have the new cameras and we can probably deploy them on the net and also maybe in front of the net with some tripods, underwater tripods, these cameras will have an amazing field of view, more than 120 degrees. There'll be 4K cameras, high definition cameras. So we should be able to get what we are looking for. That's my hope, and I really like to finish a project. So yes, I hope we can come back and tell everybody what's going on down there. Yes, that's my hope.
Thanks, Alex.
You're welcome.
There's a couple more questions from the audience here. One of them was, how far out to sea do the seals venture? There's a lot of folks that work on tagging these animals, tagging and tracking, and they do roam far and wide. These are animals that move relatively regularly from Cape Cod up to the coast off Nova Scotia and back. The more we tag these animals, the more we see. Another question I got, this is one for the fishermen on the group here. How do gillnets interact with dragging?
That's a really good question. So it doesn't anymore. It did back in the codfish days. You'd come out to find your gear, and they'd just be high flyers and balls. That was a big problem back in the cod fishing days. It is not an issue nowadays. The only rub up we have is with scallopers, but we talk to all the scallopers and they stop at a certain line, and we just set west of that line. But as far as draggers, there are no more big draggers. The Knobsker and all them out of Gloucester and Point Judith and New Bedford they're all out in the deep water towing for what's left, but the inshore grounds don't produce ground fish for them to come in and hit us anymore. I hope that answered your question, but times have changed. Before, like I said, there were draggers everywhere. Now, not so much.
Yeah, I think that summarizes it for a lot of things. Is times have changed. I think what I'll do, I had one request from the audience. There's still a couple more questions here, but we're running right up to the end here. I'd like to close on a note here. So if anybody has follow-up questions, they're welcome to email me. My email address is nichols@coastalstudies.org. You can find us pretty easily on the web at www.coastalstudies.org. I'm going to put one last video clip up if I can here per audience request. We'll see if I can share it, and then we'll close on this note. For anybody who wants to stick around and watch this last couple minutes, I'll narrate it here. But I want to thank you all for joining us today. You know, this is kind of a unique discussion that we had today, where we've literally have fishermen calling in from their boats. You know, and with that comes, of course, the technical glitches, but it actually worked remarkably well, all things considered. So I want to thank Alex and Doug for joining us today. I want to thank our audience for asking so many great questions. You know, this is why we do the work that we do, to go out and answer questions that the community has. I'm going to close with this last little bit of video here, but we do hope to hear from you soon. If anyone has any follow-up questions, please reach out to us. We're pretty easy to find. But I'm going to put up this last bit of video here. This is one of the students that we worked with just sent this to me yesterday. Let me see if I can pull that up there. There we go. You guys see a video?
Yep.
Great. So I'll hit play here. We'll close on this note. There's that crab again, but what you see at the top, that is an Atlantic torpedo. It's a very large ray. And good news for this fish, it's kind of blundered into the gillnet a little bit. It's moved along the gillnet. It's a big animal, too big to easily get meshed in there, and it's turned around and it's gone the other way. That Atlantic torpedo is a pretty amazing fish. I'll go back to it again here. Our students got really excited when they saw this. You see it coming in on the right-hand side of your screen. That's a big animal there. Atlantic torpedoes are electric fish. They have an electric organ that they can use to stun predators or prey. Doug's probably happy that wasn't stuck in the net when he brought it back on board. And you see that fish swimming away there unharmed and not interacting with the net. I think we'll close on that positive note for everyone. Again, thank you all for joining us today. Really enjoyed doing this with you all. Stay tuned to the Center for Coastal Studies for our next Dockside chat. I don't know if Catherine may still be here, if she's not able to be on here anymore, but please do stay tuned, check our Facebook, check our website, get on our mailing list if you're not there already. And we hope to hear from you again. Hope you'll join us next time. Thanks again, everyone.